find the area bounded by the line x is equal to 0, which is the y-axis, x is equal to pi, which is this vertical line, 2 plus x all over 2, and cosine of x. So that's this region shaded in purple. In order to find the area of a region bounded by curves, we need to use definite integrals. So the definite integral that's going to define this area will be the integral of the function that plots all of these distances. So at a given x value, we have this y value minus this y value, and that length is then going to be our function's output at that x value, at that particular x value. And likewise, at that particular x value, we're going to have that y value minus that y value. So it's that length. So if we sum the infinite amount of lengths that are in between these curves, using integration, we will find the area bounded by these two curves. So we need to find the length between these two curves. So in order to do that, we take the top curve minus the bottom curve. So the top curve is 2 plus x over 2, and our bottom curve is cosine of x. So by subtracting the two, we will be getting the distance between these two curves at a particular x value. But now we need to integrate between 0 and pi. So our bounds for integration is 0 and pi. And of course, 2 plus x over 2 is not always above cosine of x. For example, if we were to continue this graph on the left-hand side, you see that it actually dips below cosine of x at x equal to 0 if we go in the negative direction. But in the area that we are concerned with, which is between 0 and pi, it is always going to be greater than that. So that's the integral that we need to solve. Okay, so this right here can be split into 1 plus x over 2 minus cosine of x, and we're still doing the integral of that from 0 to pi in terms of x. Okay, so these are now simple integrals that we can solve individually. So the integral of 1 is just going to be x. The integral of x over 2 is going to be x squared over 4, because we've increased the exponent by 1 and we've divided by 2. So if we are dividing by 2 twice, we have x squared over 4. Okay, and then the integral of cosine of x is sine of x, so the integral of negative cosine of x is negative sine of x. And this is being integrated from 0 to pi. So our bounds now are 0 and pi. Now, if we substitute in pi into this equation, we get pi plus pi to the power of 2 over 4 minus, and sine of pi is going to be 0. And then we're going to subtract this function at 0. So we're substituting in 0 now. So x at 0 is just is just 0. And x squared over 4 at 0 is still 0. And sine of 0 is 0. So that simply leaves us with pi plus pi squared over 4 units squared as our area for this purple and yellow region shaded in the diagram. I hope you found this video useful and interesting, and if you did, please don't forget to leave it a like and subscribe to my channel. Thank you for watching.